students. So before starting the solid geometry, that is three important figures, solid figure we are going to learn: sphere, cone and cylinder. For that we need some prerequisites, that is formulae on right line and the plane, which already studied in 12th standard. So first one is distance formula is there. The distance of the point P x1 y1 z1 and Q x2 y2 z2 is PQ is equal to root of x2 minus x1 bracket square plus y2 minus y1 bracket square plus z2 minus z1 bracket square. Distance between the points P and Q, it is given by this. Then next point is direction cosines and direction ratios. So you are aware that cosine of the angle made by some line with x, y and z axis, that is cos alpha, cos beta and cos gamma, is nothing but the direction cosines of the line. It is normally denoted by LMN, where L square, the relations, if you try to prove it, is L square plus M square plus N square is equal to 1. Similarly, direction ratios, these are proportional to direction cosines, that is L upon A plus M upon A plus N upon M upon B plus N upon C is equal to say some constant here. It is 1 upon plus or minus root of A square plus B square plus C square plus or minus, of course. So you are getting L is equal to A upon this thing, M is equal to B upon, means these are relation between direction cosines and direction ratios. We need this. Similarly, equation of plane. So you are aware the general equation of first degree in x, y, z, ax plus by plus cz plus d is equal to 0 represents plane actually. Then the equation of line passing through the points a x1 y1 z1 b x2 y2 z2 is this. Actually, this is also called symmetrical form of the equation of line. It is this: x minus x1 upon a, y minus y1 upon b, z minus z1 upon c is the symmetrical form of the equation of right line. 2 points on the line it is given, and A, B, C are called direction ratios. Direction ratios of the line, you would like to write down general point on the line. It is given by x is equal to ak plus x1, y is equal to bk plus y1. If you compare second ratio with k, last one, and z is equal to ck plus z1. So this is called general point on the line. Direction ratios of the line joining these 2 points a x1 y1 z1 b x2 y2 z2 is x2 minus x1 y2 minus y1 z2 minus z1. These are denoted by ABC. ABC are normally direction ratios, LMN are direction cosines. Now angle between two lines L1 and L2, this is important formula we need in the cone. Actually, to study the right circular cone, angle between two lines L1 and L2, it is direction ratios of L1 ABC, direction ratios of L2 A dash B dash C dash. Then angle between this is given by A dash plus B dash plus C dash upon this root of A square plus B square plus C square and so on. Now perpendicular distance from a point P x1 y1 z1 to the plane, perpendicular distance from a point on the plane. Point on the plane, it is given by this. This is perpendicular distance from a point. This is point P. It is given by root of mod of a absolute value, positive value, ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. This is perpendicular distance from the point P x1 y1 z1 to the plane. It is the equation of the plane. It is given by the formula, and it is normally d upon this if it is perpendicular distance from the origin. Projection formula. Now here this projection formula, it is important. If you are having the line, 2 points on the line, and if you take projection on another line, if these are direction cosines, then projection of this line AB on line TM, it is given by Tm is equal to L x minus x1 plus M y minus y1 plus N Z minus Z1 and so on. So this is the uh, general prerequisites for to learn right circular cone, right circular cylinder and the sphere. So dear students, we are going to learn right circular cone and after this right circular cylinder. So right circular cone, I have drawn the figure here. A right circular cone is surface generated by variable straight line which passes through a fixed point and makes constant angle with some fixed line. That fixed line is axis of the cone, variable straight line is generator and fixed point is vertex. So a right circular cone is surface generated by, this is variable straight line which is generator, this is generator which passes through a fixed point. This is fixed point, this is called vertex of the cone and makes constant angle. This line makes constant angle with some fixed line. This is called axis of the right circular cone. Constant angle with fixed line. So this line making constant angle with fixed line, that is called semi-vertical angle. So that is what the definition of right circular cone. Now to find the equation of right circular cone with vertex at some particular point V alpha beta gamma, semi-vertical angle is theta and axis is the line x minus alpha upon L, y minus beta upon m and z minus gamma upon n. So how to find out this? So this is procedure for this. Let p, x, y, z be any point on the surface of the cone. P, x, y, z be any point I have considered on the surface of the cone or the generator. So what we do here, so direction ratios of VP are VP. So if 2 points on the line are given, x, y, z, alpha, beta, gamma, then direction ratios of this line, x minus alpha, y minus beta, z minus gamma. Similarly, direction ratios of the axis L, that is given by LMN. So we use the formula to find angle between two lines if the direction ratios are known. So direction ratios of VP are known, direction ratios of L axis are known. So cosine of the angle theta, it is given by L using the formula A dash plus B dash plus C dash upon root of A square plus B square plus C square root of A dash square plus B dash square, that formula. So we write angle between two lines here, cos theta is equal to L x minus alpha plus m y minus beta plus n z minus gamma divided by root of this thing, squaring and simplifying. So if you square on both sides, you are getting cos square theta and square root will be, radical sign will be removed here and it is taken cross multiplication after this. It is L square plus m square, then square this thing also it is here and this whole square. So this thing it is here. So this is on simplification gives the required equation of right circular cone. Required equation of right circular cone. Now here, if you need to, if the vertex is at, there are different cases. You can just check out vertex at origin. If the vertex at origin, then we put alpha, beta, gamma. It is 0 over here. If vertex at origin, then just putting here alpha, beta, gamma, you are getting the requisite equation of the right circular cone over here. Now, if the axis also, if it is z-axis, x-axis, y-axis, then you can take the direction ratios of x-axis. It is 1, 0, 0. Direction ratios of y-axis means LMN. It is there. It is 0, 1, 0. Direction ratios of z-axis are 0, 0, 1 and so on. Accordingly, you can modify that equation and get the equation of right circular cone. Now, let us see some illustrated examples on this. Find the equation. First example. Find the equation of right circular cone right circular cone with vertex at 1 2 3 1 2 3. Axis is the line. Axis is x minus 1 upon 2, y minus 2 upon minus 1, z minus 3 upon 4, and semi-vertical angle is 60 degree. Solution for this. So we try to find the equation of this right circular cone. Now I draw the figure here. So it would be something like this. This figure with the cone. It is right circular cone. If you take section of this right circular cone perpendicular to the axis, you are getting circle, and it is something like this. So this is axis. This is angle. Semi-vertical angle, it is theta, and it is given as 60 degree. Vertex it is given here, it is 1 2 3. Vertex it is 1 2 3, and equation of axis it is x minus 1 upon 2, y minus 2 upon minus 1, and z minus 3 upon 4, and so on. So this is the requisite figure for this p x y z. Let p x y z be any point. Let p x y z be any point on the surface of or the generator surface of right circular cone. Surface of right circular cone. So direction ratios of VP are x minus 1, y minus 1, y minus 2, and z minus 3. So it is x minus 1, y minus 2, and z minus 3. So something like this. So these are the direction ratios. Direction ratios of axis are 2 minus 1 4. So these are direction ratios. L x minus x1 alpha upon L. These are L, M, N. These are direction ratios. So angle. So we write down formula for angle. Angle between VP and axis. Angle between VP and axis is cos theta is equal to 2 into x minus 1 minus 1 into y minus 2 plus 4 into z minus 3 divided by root of L square plus M square, 4 plus 1 plus 16, and this one is x minus 1 bracket square plus y minus 2 bracket square plus z minus 3 bracket square. So theta is 60 degree here. So cos 60, this theta I will put. So this is equal to half cos 60. It is half cos pi by 3. So I just simplify this. 2x minus y plus 4 times z minus 2 plus 2 and minus 12. It is something like this, and root of this is 21, and it is root of x minus 1 bracket square plus y minus 2 bracket square plus z minus 3 bracket square. So if you simplify this, it would be, I just this gets cancelled from here. So I just square it on both sides. Squaring on both sides. Squaring, it is 1 by 4, and this I can write down 2x minus y plus 4z minus 12 it is something bracket square divided by 21 x minus 1 bracket square plus y minus 2 bracket square plus z minus 3 bracket square. Now to simplify this, to open this bracket, we use the formula a plus b plus c bracket square. This is equal to a square plus b square plus c square plus 2 times ab plus 2 times bc plus 2 times ca. This formula we are using. So I just take the cross multiplication here. So this implies 21 inside the bracket. You are getting x minus 1. We can open this bracket plus y minus 2 bracket square plus z minus 3 bracket square, and this is equal to, that is 4 times 2x minus y plus 4 times z minus 12. So I can say this is a, this is b, this is c, and open it and simplify this. You are getting the required equation of simplifying, and you are getting the required equation. If you just check out this would be the required equation here. 9x square plus 21y square minus 39z square plus 16xy minus 64xz plus 32yz plus 142 x minus 4y plus 2234 z minus 226. This is equal to 0. So this is required equation of the right circular cone. So this is the way procedure we are using. Figure, then we write down axis, then semi-vertical angle. So we take some point there, any point, then we write down direction ratios of VP, that line or the generator, direction ratios of the axis, and we use the fact the angle between radius vector, angle between VP, that is generator, and the axis. So that formula we are using, and just simplifying, you are getting required equation of the right circular cone after simplification. Go for the next example on this. Second example, find the equation, second sum, find the equation of right circular cone with which passes through this point, passes through 1 1 2. Axis is 6x is equal to minus 3y is equal to 4z, and vertex at origin, Now here semi-vertical angle is not given, so we need to find semi-vertical angle. This equation, we divide by 12, then this dividing by 12, x upon 2, y upon minus 4, and z upon 3. So this could be given in this form here, 2, minus 4, and 12. So if you observe here, solution, actually to find the equation of right circular cone, we need vertex, we need semi-vertical angle here, and axis. So how it is done? See, we draw the figure to find the equation of right circular cone here. I just draw the figure. So it would be something vertex at origin, semi-vertical angle is theta. It is not known. We have to find out this angle, and axis it is given as x upon 2, y upon minus 4, z upon 3. So we find out this, and it passes through the point. It is some point it is given here. It is M1, 1, 2. So we can find out angle here. So we need to find angle that is semi-vertical angle. We need to find semi-vertical angle. This point is M, any point on this. So to find semi-vertical angle, so if it is required, then only we can find the equation of cone. So what direction ratios of VM are 1 minus 0, 1 minus 0, 2 means 1, 1, 2. Direction ratios of axis are direction ratios of axis are 2, minus 4, 3. So semi-vertical angle. So we find the angle, semi-vertical angle, angle between VM and axis is cos theta is equal to this formula, a dash plus b dash plus c dash divided by root of a square plus b square plus c square. This formula we are using, a dash square plus b dash square, where a dash, b dash, c dash are direction ratios of this. So a dash means 1 into 2 plus b dash means this is ABC. This is A, this is B, this is C. This is A dash, this is B dash, and this is C dash. A dash means 1 into 2, 1 into minus 4, and plus 2 into 3 divided by root of a square, 1 plus 1 plus 4, and here it is root of 4 plus 16 plus 9. So it is something, this angle cos theta you are getting, this is equal to 2 minus 4 plus 6 divided by root of, this is root 6, and here it is 29, it is this is equal to 8, means 4 upon something, root 6 into root 29. So cos theta is this. So this is angle. Now we take some point pxyz. This point, let pxyz, to find the equation now, pxyz be any point on the surface of cone, right circular cone. So what are the direction ratios? Direction ratios of VP are x minus 0, y minus 0, z minus 0, means it is x, y and z. Direction ratios of axis are 2, minus 4 and 3. So again using angle between VP and axis is cos theta is equal to same formula again, it is 2 into x minus or it is this x into 2 minus 4 into y plus so it is something x into 2 plus y into minus 4 plus z into 3 divided by root of x square plus y square plus z square, and root of it is this 4 plus 16 plus 9. So it is this value I have to put here. It is 4 upon this value. I put it here, root 6 root 29. So I can cancel out this value here, root 29 on both sides, and I simplify this further. On squaring on both sides, it is 16 upon 6. This is equal to 2x minus 4y plus 3 times z bracket square divided by x square plus y square plus z square. So this is on squaring both sides. Squaring this expression on both sides, you are getting this. So I just cross multiply. I take this term on this side, this term on this side. So what happens there? If you simplify this, you are getting here it is 16 multiplied by x square plus y square plus z square, and this is equal to 6 times 2x minus 4y plus 3 times z bracket square, and again the same formula, a square plus b bracket square. It is a square plus b square plus c square plus 2ab plus 2bc, and on simplification you are getting the required equation of right circular cone, and it is given by 4x square on simplification, 4x square plus 40y square plus 19z square minus 48xy minus 72yz plus 36zx. So this is required equation of right circular cone. On further simplification. That's all. So next example on this. Find the equation of problem number 3. Find the equation of right circular cone with vertex at origin. Axis is x upon 1, y upon 2, z upon 3, and theta is equal to 30 degree, means semi-vertical angle is 30 degree. Now we have to find the equation of right circular cone here. Solution, I draw the figure for this. So figure is this. Vertex at origin. So this angle is 30 degree. And this is axis. Axis is x upon 1, y upon 2, z upon 3. And let pxyz be any point. So we start with let pxyz be any point on the surface of cone, surface of right circular cone, and direction ratios. Therefore, direction ratios of VP are x minus 0. So the formula x minus 0, y minus 0, z minus 0. Same procedure. And direction ratios of axis are 1, 2, 3. Direction ratios of VP axis are 1, 2, 3. Therefore, angle between VP and axis is given by the formula. It is given by cos theta is equal to axis is, this is equal to, using the formula, it is x means x, y and z over here. It is x into 1 plus y into 2 plus z into 3 divided by, so this value cos 30, because the angle is given as 30 degree. So if you simplify this, root of x square plus y square plus z square, root of 1 plus 4 plus 9. So we simplify this, cos 30, it is root 3 by 2, cos 30, and here you are getting x plus 2y plus 3z divided by root of x square plus y square plus z square, and root of this is 14. So it is something like this you are getting. If you simplify this, because cos 30 is root 3 by 2. Now on squaring both sides, to square it on both sides, then 3 by 4. On squaring this, you are getting 3 by 4 x plus 2y plus 3z bracket square divided by x square plus 4 times 14 times x square plus y square plus z square. Now if you take the cross multiplication of this, then further simplification, you are getting this as this 42, or it is something like this, this is 2 and this is 7. So it is 21 multiplied by x square plus y square plus z square. This is equal to 2 times x plus 2y plus 3z bracket square. So if you simplify this, 21x square plus 21y square plus 21z square, this is equal to 2 times, I again use the formula, a plus b plus c means a square means this 4y square b square plus c square means 9z square plus 2 times here, you mean 4 times xy plus 12 times yz plus 6 times xz. So if you just simplify this and rearrange the term and get the required equation of the right circular cone as 19x square plus 13y square plus 3z square minus 8xy minus 2 times xz minus 24yz, this is equal to 0. So this is required equation. On simplification, you are getting the required equation of right circular cone.